zero, a topic close to all of our hearts. Kenneth.
Thank you very much for having me here. I'm very happy to present this renewed commitment to Vision Zero. I would like to start by presenting a scenario for you. Imagine two cars driving after each other like this. The driver of the red car here believes that the driver of the blue car is driving too slow, so he decides to overtake that car, and he does. And when the cars are parallel like this, the blue car has a speed of 50 kilometers per hour, and the red car has a speed of 60 kilometers per hour. And then something happens in front of them, and they have to brake as hard as they can in order to stop the cars. And the question I would like to ask you now: what speed will the red car have when the blue car has stopped? Please, feel free to guess. I present this scenario for students every year at Chalmers University in Gothenburg, and have a lot of interesting guesses. 25? 45? Good guesses? Okay, I will present the result, the answer, in a minute. But it has to do with the basic physics, kinetic energy, the energy of a moving body. And that is this formula: the mass multiplied with the velocity in square divided with 2. So if you increase the speed, if you double the speed, the energy will not be double, it will be 4 times as much. And this, of course, has an impact on stopping distance. And I have this slide here that shows stopping distance and collision speed. And we imagine here that it's fast reaction time by the driver, 1 second, hard braking on dry asphalt, so it's perfect conditions. So if we think of the car that was driving in 50 kilometers per hour, first here we have the velocity, kilometer per hour, and here we have stopping distance in meter. So first it's the reaction time, and then there is no reduction in speed. And then the driver starts to brake, and after some 27 meters, that car has stopped. And then we think of the other car that was driving in 60 kilometers per hour, the same thing here, the reaction time, no reduction in speed, and then that car starts to brake. And after some 34 meters, that car has stopped. So at the point when the first car has stopped, the speed of the other car that was driving in 60 kilometers per hour is still some 40 plus kilometer per hour. So I don't know who said 45, but a good guess. Very good. And of course, this has a huge impact also on the consequences of an impact if there is an accident. Because we humans are not designed to understand that speed is something dangerous. We can drive a car in 90 kilometers per hour and we still find out that people are not wearing seatbelt. But if you were working on the 10th floor of a building and do some maintenance work, you would for sure have some kind of safety equipment, because we feel that that is something dangerous. And this is very difficult to communicate, that speed can be dangerous if there is a sudden stop. I also used to show this picture for my students. Usain Bolt, I think he still is the fastest man on earth. He has the world record of 100 meter, 9.58 seconds. And the mean speed then will be 38 kilometers per hour, and the peak speed is 40 plus something. But imagine, instead of crossing the finishing line, Usain Bolt would crash into a brick wall. What would happen with him then? He would probably survive. He's young, he's well trained, but he would certain suffer some injuries. Maybe he will have a skull fracture, maybe a broken leg or something. But this is what we humans are designed for, to tolerate the impact of the kind of speed that we ourselves can produce. So when we come over that speed, we need to have extra safety equipment. And as I said, speed, and if there is a collision, has a great impact on the risk for injuries and death. So here we have a slide about the risk to be killed in collision speed. So if you're a pedestrian and if you're hit by a car in some 30 kilometers per hour, most of those cases it will be quite okay. The pedestrian will survive. But if the pedestrian is hit in some 50 or 60 kilometers per hour, many of those accidents will be fatal. And it's the same if there's a side-on collision, one car hitting the other car in the side like this. For those riding in that car that is hit, if the speed is some 50 kilometers per hour, then the car can absorb much of the energy. But if the speed is 70 or 80 kilometers per hour, then there's a very high risk of fatality. And the same for head-on collisions. If there is a head-on collision in 70, 80 kilometers per hour, most cases can be quite okay. But if the speed is 90, 100 kilometers per hour and there is a head-on collision, those crashes are many times fatal. So, why have I presented these slides for you? It has to do with the principles of Vision Zero. And what is Vision Zero? It's an ethical standpoint that no one should be killed or suffer lifelong injury in road traffic. And as we heard before, road users will all make errors, and that is something we have to take into account when we design our roads. And the level of violence that a human body can tolerate without being killed or seriously injured shall be the basic parameters in the design of the road transport system. So we have to take the human tolerance into consideration when constructing and maintain, and also when we maintain roads. Some other things about Vision Zero. System designers, they can be those who are responsible for the road authority, but it can also be lawmakers, car manufacturers. They are responsible for the design, operation, and use of the road transport system, and thereby responsible for the level of safety with the entire system. But the road user, of course, they are responsible for following the rules for using the road transport system set by the system designers. But if the road user failed to comply with these rules, due to lack of knowledge, acceptance, or ability, the system designers are required to take the necessary further steps to counteract people being killed or injured. This was actually written in 1997 when the Vision Zero was introduced. So what is interesting with this is there is a loop back to the system designer. So we just can't say that we build a road and see that people are being killed there, and we say, okay, that's up to the road user. The system designer has to take responsibility, even though the road users are not complying with the rules. And we heard before about roundabouts. The picture to the right, there you have a roundabout. The picture to the left is how it looked before. It's a normal intersection with traffic light. And that is a good traffic solution, maybe in urban areas. It handle the traffic flow in a good way. But if a road user make a mistake here and misses the red light, then there can be a crash, a side-on collision like that can be critical. On the picture to the right, it has been reconstructed to a roundabout. And the level of energy, if there is a crash in that situation, is much less severe it will be another kind of crash. But what is interesting with these two pictures here, the number of accidents in these both cases are approximately the same, but the outcome of the accident is much, it's not as severe in the roundabout situation. So this is a Vision Zero solution. In Sweden, we have had quite many wide roads, 13-meter wide roads, and we have had speed 80 kilometers, no, 90 kilometers, or before we even had higher speeds on these kinds of roads. But we have a lot of fatal accidents, a lot of head-on collisions with fatal consequences. We have rebuilt many of these roads to what we call 2+1 roads. We have 2 lanes in one direction, then we have a middle barrier, and then we have 1 lane in the other direction, and then that alternates. So we control the oncoming traffic, and we also control the overtaking when the road users can overtake. And that has reduced the number of fatal accidents on these wide 13-meter roads with some 80%. So that is a fantastic result. And this was a consequence of the introduction of Vision Zero. We had to think in new terms. Another good solution is a modern camera system for speed surveillance. For example, if we build a road and say that this road is suitable for 70 kilometers per hour, but we later find out that road users are speeding, it's 80 or 90 kilometers per hour, then we can't just say, okay, that's up to the road user. We have said that it should be 70 kilometers per hour. No, then, as you remember, there's this loop back to the system designer. And this can be one of these solutions then, that you have a camera surveillance system in order to reduce the speed on that kind of road. Okay, now I've been talking about Vision Zero, but I was supposed to talk about the new commitment to Vision Zero. And why does the Swedish government believe that we have to have a new commitment to Vision Zero? One of the answers is this one. Here we see the fatalities in road traffic accidents in Sweden since the introduction of Vision Zero in 1997. In 2016, we had 270 fatalities in road traffic in Sweden, and we have a target when it comes to 2020 that no more than 220 persons should be killed in road traffic accidents. But as you can see, the number of fatalities has leveled off, and that is a concern in Sweden. And this is something that has been seen not only in Sweden, but in many countries. Another thing that we are a bit concerned of, or an interesting finding, is that we have looked into the fatalities among protected road users and unprotected road users. The blue line here represent those who are protected, people who are basically sitting inside cars. The number of fatalities in that for that kind of road user have been increasing dramatically. The number of fatalities have been continuously going down. But when you look into unprotected road users, like pedestrians, riders of bikes, riders of motorbikes, those fatalities has not been going down as quickly. So now these two groups, the number of fatalities are almost equal. And this can also be seen when it comes to injuries. And I have some data from people that are hospitalized because of traffic accidents. And here we compare drivers or protected road users compared with the bicyclists. And something happens there 2008, 2009. Now actually in Sweden, more people are hospitalized when having a traffic accident riding a bike compared with persons inside cars. So unprotected road users is a concern in Sweden. We have to improve the traffic safety for unprotected road users in Sweden. So these are reasons why we have to have a new commitment for the Vision Zero in Sweden. So what the Swedish government has said is that continued transport safety work should proceed from three perspectives. We should firmly establish and reinforce work that is already delivering result. For example, we should continue to build these 2+1 roads, for example, but we also have to develop and include new areas in transport safety. For example, we have to make the traffic safety for unprotected road users safer. And the third point here is that we have to adapt transport safety. The technology in cars is progressing and improving fast. We have, for example, lane departure warning system, and they depend on the road markings on roads. So we have to have good maintenance, good road markings, in order to have these system in cars to function in the way that they are supposed to do. So the car manufacturers and the transport administration have to work together in order to improve the safety. So what have been the results of the relaunch of Vision Zero so far? I've written down leadership and cooperation. The Swedish government has said that the Swedish transport administration has to take the lead when it comes to traffic safety in Sweden, in cooperation with other organizations as well. But the Swedish transport administration will take the lead, and we are right in the middle of that process now. And we have also looked into new interim targets for 2030. We will have new goals when it comes to fatality in road traffic accidents, but we will also have rules when it comes to suicides in road traffic. In Sweden, some 10% of all the fatalities in road traffic are actually suicides. And the Swedish government has said that this is something we also have to address. And also goals when it comes to severely injured, of course. We have also worked a lot with reduced speed limits, both in urban areas and in rural areas. We are reducing the speed limits on rural roads. We have had before many roads with 90 kilometers per hour, and we are progressing to reduce the speed on those roads to 80 kilometers per hour. And I've heard that you have done this in France as well with quite good results. And also one result of this new relaunch of Vision Zero is that we would like to see increased international engagement, that Sweden will be more engaged internationally. We need to have more knowledge from other countries how they work with traffic safety, but also be able to influence standards and things like that are international. So I've been talking about Vision Zero, and as last slide here, I would like to, if you would like to know more about Vision Zero, last year we had the first international course in Vision Zero in Sweden. And here you can see those who attended that event. And we have a new event this autumn, September 24th to 28th. So if you're interested, please check out the website. Thank you very much for your attention.
Thank you very much, Kenneth. As I said earlier, we'll do a panel session at the end, but are there any burning questions for Kenneth while he's on stage that you may wish to ask while it's at the forefront of your mind?